Welcome back to this video, and today we will look into literals and operators. So what is a literals? Integer like 1, float 1.2, characters, string, boolean, and unit type. The empty can be expressed using literals. And integer can alternatively be expressed using hexadecimal, octal, or binary notation using this prefix. So 0 small x, 0 small o, and 0 small b for hexadecimal, octal, and binary notation respectively. Now, if we are having a large number, we can use this kind of notation by using an underscore. For example, this 1_000 is same as 1000. And similarly, for this 0.000_0001 is same as this representation. Now, we can also tell the compiler that what is the type of literals. For example, we'll use unsigned 32 suffix to indicate that the literal is unsigned, and then I32 suffix to indicate that it is assigned 32 bits integer. So that is it for literals. And we'll look into the operator in Rust. So the precedence in Rust is similar to other C-like languages, and we'll look into that using example. Now let's open again the code editor, and here I'll have literal example. Extension is rs, and let me create a function main, and this is the starting point of your Rust program. And the first thing is we'll do the addition, integer addition. So this is a very simple addition of two literals. I'll say 1 plus 2 equal to the number. So of course it will be 1 plus 2. Now I'll copy this, paste it here, and I can also specify the type, that is unsigned 32, or I can have I32. So we have an addition of unsigned and signed. Now we can also use, let's say we can have a subtraction. This is for integers subtraction. Now let's look at this example and see what will be the output. Now to compile this, again, we are using Rust example, and look, we have something else. Expected unsigned 32 found I32. And if you look at the other line, that is no implementation for the addition of an unsigned and signed. So that is an error. So this is nice because we cannot add a signed and an unsigned. So we have to specify these two types to be the same. So let's compile this. So it compiles successfully. And maybe let's look at the output. So I think this is correct. Yes, correct. Okay, and one more thing here is we are surprised to see, or excited to see, that have some explanation, and we can do that. I think this is interesting for us and also for the viewers to know what is this. So let's look at the explanation of that. So what is the explanation? You try to use a type which doesn't implement some trait in place which expected that trait. So basically we are trying to add two, one is signed and one is unsigned, in which Rust does not have that implementation to do this operation. So that is nice. So we can stop this as for now. Let's go back to the program. And next is, let's look at subtraction of two number. That is, this is an unsigned 32 bits. Oh, sorry, signed 32 bits. And let's compile it. Okay, this is the other one. and we have one, just a minute, this should be 1 minus 2. So we have 1 minus 2 is equal to minus 1, which is correct, right? So what we can do now is, let's look at this and change it to unsigned 32 bits. Will this work? Let's check it out. Oh, this is again an error saying attempt to compute the unsigned minus unsigned 32, which would overflow. Of course, because we cannot have a minus in unsigned. So this actually be a result of -1, which will be overflow for the unsigned type. So this is for the addition of the addition subtraction of two integers, and we can have multiplication as well. We can have divide as well, just like any other operator. Now we look into bitwise operator, and let's take a printout, and this is a 1000 and 1100 equal to some output, and to specify literal of the notation of bit, we have to put 0 BE prefix, and then followed by the bits, the binary, and then a single ampersand. Get the same thing. That's it. So now let's compile it.
What are the bang symbol in the print?
Okay, we need the bang because this is a macro. Yes, fantastic. Okay, so we have 8 as the output, I think, which is fine. And then we will need to format this to have a 4 kind of a precision and of type bit. So there we go. So same thing we can do it for OR by replacing this with this symbol and pipe symbol, and then we can also use the XOR symbol and the other operator. So this is for the bitwise operator, and then we can also have the bitwise shift left or shift right. That is, we can have a number and we want to shift 5 bits to the left. This will be equal to some number, and this is shift 5 to the left. Okay, we need this one, and here we go. So that's it for today, and let's explore tomorrow for tuples and array and slice. Thank you.